Okay, yeah, you're going to want to open up the lecture quiz Rocks 1, because that's going to go along with this. Here we go.
The rock cycle, which is the process of making, changing, and destroying rocks, can take over 1,000,000 years. What are some of the forces at work during this cycle? We live on a planet whose crust is kilometers thick with rock. Rock is the basic unit that makes up our solid Earth. It supports everything from the ground we walk on to our oceans, our deserts, and mountains. When we talk about rocks, we're also talking about minerals. All rocks are made from more than one mineral. Geologists define a mineral as a naturally occurring solid that has a distinct chemical composition and consistent internal structure. The Earth is constantly changing, and so are the rocks and minerals it contains. They get redistributed and recycled over and over again in a process called the rock cycle. Over millions of years, rocks are continually made, changed, and destroyed. At the surface, people break down the Earth's rocks and put them to good use. Throughout history, we've learned to depend on them. Today, they help cover our roads, support our buildings, and decorate our lives. Forces of nature also take their toll on rocks at the Earth's surface. Wind, water, and gravity are always at work to wear down or erode the rocks around us. The results can be very dramatic. But for all of this destruction, new rocks are constantly forming. Some particles of rock get deposited and hardened into sedimentary rock. Others get buried, compacted, heated, and recrystallized beneath the Earth's surface and become metamorphic rock. Temperatures are so hot at great depths in the Earth that rocks and minerals often melt and become liquid. Over time, the liquid cools, creating new rocks that eventually get pushed to the surface again, forming new igneous rock. Sometimes this process happens quickly during events like volcanic eruptions and earthquakes. But most of the time, it takes millions of years. As a result of this ongoing cycle, the Earth holds a tremendous variety of rocks that differ in the minerals they contain. They vary in color, texture, and permeability, and so on. Geologists study these rocks in search of valuable clues about the history of the Earth. Like rings in a tree, they hold information about past environments and the events that formed them.
Okay, so we're going to talk rocks in this unit. We'll mostly talk about the rock cycle today and igneous rocks. Okay, and if you've got your computer open, you can answer that question when we get to it here. So let's dive into rocks right here. There's some rocks for you. Those are actually big pieces of granite right there. This is in Elephant Rock State Park. I think it's in southern Illinois, maybe. It's real close to Missouri. But this is how granite actually weathers. You can see the bottom of this one right here just peeling off, these little pieces right here, right? So it weathers into these kind of rounded boulder-shaped things, and they're pretty cool looking, really. So we're talking about igneous rocks today. Granite is definitely an igneous rock. Let's dive into the rock cycle. So a rock is any solid mass of mineral or mineral-like matter occurring naturally as part of our planet. So it has to be solid. It doesn't necessarily have to be mineral. Rocks can be made up of natural glass that's formed in volcanoes, which is not a mineral. But mineral-like matter, rocks can be made up of decomposed organisms, like in the case of coal. So coal is a rock, and it's really not mineral matter. But most rocks do contain little minerals in them. Whether you can see them or not, that's what they've got in there. Today we're talking about igneous rocks, which for the most part do contain lots of minerals in them if they're not glass. So these things are formed by the crystallization of molten magma. So if you want to write down in your question there what igneous rock is, you can get a good description right here. So you're going to write the 3 types of rocks. The first one is igneous. Okay. And I think igni means fire. Is formed by the crystallization of molten magma. Molten just means liquid. Okay. Whether it's lava or magma, it was liquid rock and then it hardened into solid rock. Okay. Crystallization of molten magma. Okay, the other 2 types of rocks. For the rest of your answer, you don't have to write all of this, but sedimentary rocks are formed from the weathered products of pre-existing rocks that have been transported, deposited, compacted, and cemented. I would actually get this whole thing down here because these words are really important. So think about a sedimentary rock as something that's been, other rocks have been ground up through weathering, okay, and erosion, and then they get transported someplace, like a river carries the little bits of rock. A windstorm carries the little bits of rock, okay? They get transported and then they get deposited, so they end up settling someplace, which is where sedimentary rocks actually get their name, sedimentary, hear it? Then they're compacted and cemented together. So it doesn't happen immediately. There has to be some weight on top of this material to compact it tightly together, and then there has to be a fluid, typically water. So these things happen like at the bottoms of the ocean, the bottoms of lakes, places where water can move through the material and then redeposit sort of some cement, some liquid that will harden into what's going to become the rock. So larger sedimentary rocks often look like little pebbles all stuck together, right, like a conglomerate would. Metamorphic rocks. So metamorphism is what a caterpillar does, right, when it becomes a butterfly. So this is a type of rock that starts out as a sedimentary and igneous or even a metamorphic rock and then gets squished and cooked for the most part. So by being heated and squished, new minerals actually form. It doesn't totally liquefy. If it totally liquefied, it would be igneous again. But it gets heated up, gets pressurized, and new minerals actually form. Striking minerals. Sometimes some of our most beautiful gemstones or minerals come from metamorphic rock. Okay? So it's formed by the alteration of pre-existing rock deep within the earth, but still in a solid state, so it doesn't liquefy. Heat, pressure, and even the fluids that might be moving through it create chemical changes. Okay? Igneous, sedimentary, metamorphic. Everybody have them? Anybody still working? Okay, I'll give you a second. Here we go. So the rock cycle is just a cycle, and it shows us the way that all these 3 different rock types interact. So any rock type can become another rock type. There's a couple of words we're going to want to know so we can understand what is going on here. Magma is any molten material, any liquid rock, if you will, that's underground. Okay? When it comes up on the surface, that's when we call it lava. So when there's a volcanic eruption going on, lava is spewing out, right? But magma is what's underneath. It's called magma till it reaches the surface. I know it seems like we're splitting hairs here, but it's kind of an important distinction if you want to know what we're all talking about. Weathering is just how rocks are broken down at Earth's surface. Has to do with climate, right? So water, air, even living things like roots growing through them, and humans, of course, we weather the heck out of some stuff, right? Acid rain, things like that. Sediment is the little bits and pieces of stuff that's been weathered, okay? So that'll help you to understand what we're going to talk about here. Here's the rock cycle. So if you missed any of those explanations on the previous page, you could jot one of these down. We can start up here at the top, and it says rocks at Earth's surface are broken down into smaller pieces called sediments, and then those go down here to the right. They get deposited, compacted, and cemented together which becomes a sedimentary rock. And then maybe a mountain starts to form. Mountains form because of tectonic plates, right? So you need a pretty serious force if you're going to squish and heat rock. So mountain formation is where we find metamorphic rocks. Going to find a lot of metamorphic rocks in Indiana? I've never seen a mountain here, so probably not, right? We do have some metamorphic rocks, but they've been drugged down from Canada. The glaciers brought them down and dropped them off. Then this could become igneous, okay? Maybe the metamorphic rock is heated down below Earth's crust, and the magma then erupts, and we end up with an igneous rock. So that's the next stage up here, the magma or the lava cooling to become an igneous rock. Now notice that any one of these could become any other. Like a sedimentary rock could get ground up and become another sedimentary rock. A metamorphic rock could become a sedimentary rock, could become an igneous rock, could become another metamorphic rock, right? It just goes back and forth in any which direction. So what's driving our whole process? What's driving this rock cycle? It's one of the few cycles on our planet that's not driven, per se, really so much by the sun as it is driven by the heat within the Earth itself. Okay? The sun does play a role. It has to do with the weathering and erosion and movement of things, because that's how weather and wind move on our planet. So the sun does have a role, but the majority of these processes, especially igneous and metamorphic rock, are driven by the heat down inside of Earth, down deep in our core, that is slowly escaping from our planet and moving the plates around. Okay, so you can think of like igneous metamorphic rocks. Those are driven by the Earth's interior, whereas the external processes like the sun, the wind, the water, those really drive the sedimentary rock cycle, portion of the cycle. So let's talk igneous rocks. That's the topic for today. There are two main groups of igneous rocks. There are intrusive and extrusive. Okay. When you squeeze the toothpaste tube, what does it do? Does it intrude or extrude? It extrudes, right? It squirts out. So extrusive igneous rocks happen when lava squirts out of the earth and hardens. Okay? Intrusive igneous rocks are like an intruder. Intruders come in, right? So intrusive igneous rocks stay underneath the earth and they cool underground. Now, why in the world would there be a difference? Well, here it is. Extrusive igneous rocks can cool very, very rapidly in like a matter of days, hours, minutes, depending on like where they're extruded. Like they could be extruded right into the ocean. Well, they're going to cool really, really fast if they're pumped right into the ocean. Something if a volcano erupts into the water. Even on the surface, they're going to cool really fast. When they cool very fast, rocks form really tiny crystals. The crystals don't have time to form. In fact, if they cool fast enough, they actually make glass. That's how you make glass. Intrusive igneous rocks, in comparison, can take thousands of years to cool. That's a long time. Like a big body of magma underneath the ground, slowly cooling off. It can take like thousands, tens of thousands of years for it to cool off. Or it could be a little faster. The slower process means that big crystals have time to form. So these rocks all have like big, chunky looking crystals in them. Granite's an example of that. You see in your countertops. You can see the crystals in it. So we'll look at a couple of these as we go here. We classify igneous rocks based on what they're made of, what stuff's in them, and what their texture looks like. Okay? So let's go through a couple of textures. The first one here is coarse-grained versus fine-grained. And I just mentioned that if the magma cools slowly, you get a coarse-grained texture. In other words, you can see the crystals with your naked eye. Okay? If it cools very fast, you get a fine-grained texture where the crystals are so small that you can't really see them with your naked eye. You need a microscope to see them. They're there, but you need a microscope. So coarse-grained versus fine-grained. You're going to do that down in lab. There's a coarse-grained rock. That is granite we were just talking about. That was the stuff that I was hanging out on in the beginning there. Do you see all the little crystals in this? You see little black ones, pink ones, white ones, gray ones. Each one of those is a different mineral. The grays are quartz. The blacks are probably biotites. You learned some of these words. The pinks are a feldspar, so are the whites. Okay. Here's a fine-grained rock. Okay. I think this is rhyolite. So you can't see, neglect these little white blotches there, but this pinkish colored material, the minerals in it are so fine, they're so tiny you can't see them. So that erupted as lava and cooled like that. Okay. There's a couple other types of textures that I want to mention. Okay. One is glassy. So a glassy texture happens when it cools really fast, and it literally is volcanic glass. This is obsidian. A porphyritic texture is one where you get different rates of cooling. So what happens is down in the magma chamber, it's underground, it starts to cool. It cools very slowly, and as it cools, big minerals start to form, big crystals. Okay? And then all of a sudden, there's an eruption, and all of that mess of stuff, which has crystals in it and still liquid magma, gets erupted as lava on the surface. And so it cools fast then. So what you end up with is this porphyritic texture where you've got big crystals intermixed in a ground mass of really fine stuff. So you might have that pink rhyolite rock that I just showed you, but inside of it there'll be little black crystals everywhere that you can see. That's what porphyritic means. Okay? All right, next let's do composition. This is the other thing you're going to have to know. So to classify these igneous rocks, you've got to figure out what texture they are. Are they fine grained, coarse grained, glassy, porphyritic? And then you ask yourself, well, what are they made up of? Well, you don't necessarily need a microscope to figure this out. Really, composition in igneous rocks comes a lot down to what color are they, which it sounds kind of simple, but you can almost get it right every time if you just look at the color. So the first group we have are called granitic because they are symbolized by the rock granite. And these rocks are made up mostly of really light colored minerals like quartz and feldspars. They might look a little pinky, but they're definitely lighter colored rock. Okay, that's granitic. Okay. Here is a glassy textured rock. This is obsidian, we just mentioned. Okay. See how it's glass, it's broken? Stuff's really sharp. Here's a porphyritic texture rock. You can see the big chunky crystals intermixed in a much finer stuff. So the big whitish colored minerals there formed underground, and then it got burped out of the ground and all the grayer colored stuff formed. Okay. The other three compositions, we had granitic. Basaltic are rocks that have really dark stuff. Okay, really dark minerals in them. Then we've got one that's in the middle, one in between granitic and basaltic, and it's called andesitic. So named because of the rock andesite. Basaltic's named after basalt. Andesitic minerals kind of fall in between in their composition and color. So they're not totally dark, they're not totally light, they're sort of an in-betweeny. And we'll get to some of those as we go. And then finally, the last one is a rock group we won't see down in lab, and it's not very common. They're called ultramafics. Ultra. In other words, they are extremely basaltic. They're like beyond the basaltic scale. Another word for basaltic is mafic. Mafic stands for magnesium feldspar, or I'm sorry, magnesium and iron, Fe. Magnesium iron. So those are very, very dark things. A lot of times they have kind of a greenish color. These come from really deep underground, like super deep. They're not common on Earth's crust, but we do have some. Okay, here's a picture of some basalt columns. So these columns are actually from, this is in Ireland, actually. And these columns, look at these perfect hexagonal columns. If you looked at them from the top, they'd look like little stop signs all packed together. This is actually right on Giant's Causeway, if you've ever heard of Giant's Causeway. This rock formed underneath the ocean. Okay, this is oceanic rock. It's basalt from the bottom of the ocean. So what happened? How did it get way up here on the top of Ireland? Well, the plates moved, and certain areas of the ocean floor got lifted up into the air, and so now we can see this really cool hexagonal basalt. But it's a very dark rock. You can see even places where it's broken. Super dark, so it's a mafic rock, basaltic, if you will. And it's got very fine-grained texture, so you can't see the minerals in it. It just basically looks black, like a dull black rock. But yeah, there it is on our surface. Pretty cool. I think people call that the organ pipe. Looks like organs, doesn't it? Kind of cool looking. All right, so now we're on to classification of igneous rocks. Here's where you're going to answer those last questions on your quiz. Okay, let me show you how you do it. It's super duper easy. So over here on this side you have texture. Up here you have chemical composition. Okay. Texture, you have coarse-grained, fine-grained, porphyritic, or glassy. So for instance, if I had a fine-grained rock, I would go across this thing and I would find the composition. Is it granitic, andesitic, basaltic? Let's say I had a fine-grained rock that was basaltic. Well, that's basalt. And so that's what you would select for that one, the answer on your quiz. Okay. What if I had a fine-grained or a coarse-grained rock that was ultramafic, peridotite? Okay. See how where they cross together? Okay. If I've got a glassy textured rock that's igneous, and it's of a very compact glass, it would be obsidian. These are not put underneath these basaltic, andesitic, and granitic, like obsidian and pumice, only because they don't really obey the rules of what color they look. That's confusing. But obsidian's a very, very dark colored rock, and we know that dark colored things are basaltic. However, its composition is really granitic. It's really made up mostly of quartz. So it doesn't fit the bill. Unless you break off a very thin piece of it, it doesn't look as clear as it should. Okay, so the coloration thing is just kind of a relative sort of doodad to help us out, and it works most of the time. Okay, so answer your questions there. If it was like coarse-grained and we had a granitic composition, you're looking at granite. See how that works? So the composition just depends on what minerals happen to be present in it. And it just so happens that granitic rocks, felsic as they're called, contain a lot of feldspar and silica-rich stuff. They're a lot lighter colored. Andesitic rocks are kind of in the middle there. And then basaltic or mafic rocks are really dark on the other end because they contain dark minerals. Okay. And then there's the ultramafics that even go kind of look a little bit green. You see they've got olivine in there. Those come from deep, deep, deep within the earth, like upper mantle material. Yeah. Okay, that's it for today. Answer your questions and you're done.